Hey there, welcome to 8-4. We are talking L'Hopital's rule. We're going to go ahead and look at some limits, a blast from the past, and what we're going to find is that when we do algebraic substitution, we're going to reach an indeterminate form, either 0, 0, or 0 over 0, or in positive or minus infinity over positive or minus infinity. All right, what we do from there was first introduced to the mathematics world by French nobleman Marquis de L'Hopital. That's how you say it, L'Hopital. And not actually by him, he actually bought the rights to it. But we're going to go ahead and explore L'Hopital's rule, which is pretty straightforward. All right, so some limits cannot be found using algebraic methods. If direct substitution produces one of these two indeterminate forms, and here they are, 0 over 0 or plus or minus infinity over plus or minus infinity, then a rule known as L'Hopital's rule may help you find the limit. Okay, and here's what L'Hopital's rule says. It says if the limit as x approaches c of the function equals 0, and as well as the function of the bottom approaches 0, or if they're both positive or minus infinity, right? Hint, hint, the indeterminate forms. Then what we can do is go ahead and calculate the derivative of the top and the derivative of the bottom, and we utilize that in our limit. And it's pretty simple. So it says here, to use L'Hopital's rule, you need the limit of an expression written in fractional form. So here we go. We're going to apply L'Hopital's rule. And we have the limit as x goes to infinity of x over e to the x. Okay, so if I go ahead and plug in infinity, then this is infinity. And if I plug in infinity here, e to the power of infinity, that is also infinity. Okay, so notice that is indeterminate form. So I can go ahead, and L'Hopital's rule says I can take the limit as x goes to infinity of the derivative of the top. Okay, so the derivative of x is just 1, and the derivative of the denominator is e to the x. Okay, and now I can evaluate the limit. So if I plug in infinity for x, we get 1 over infinity. And that is just 0. And there you have it. Okay? Very straightforward. And I want to point out, too, notice how I did not, and maybe don't write this down. Are you listening? Do not write this down. Notice how I did not say that this is equal to infinity over infinity. If you do this on the calculus, on the AP exam, you will lose the point. Do not write that. That's why I use arrows when I'm just kind of like investigating. Like, this smells like L'Hopital. Right? So don't put equals, okay? That's what I was trying to say there. Sorry for being weird. Okay, we're going to go ahead and do it again. The limit as x goes to infinity of e to the x over x. Okay, so I plug in infinity, and this goes to infinity. I plug in infinity in the denominator, and this goes to infinity. So I can go ahead and I can take the derivative. That's what L'Hopital says. And it's not the derivative of the whole thing. Notice you're not doing quotient rule, okay? It's just simply, like, look up here, right? Limit of f of x over g of x. So it's now the limit of f prime of x over g prime of x. So what's the derivative of e to the x? E to the x, right? The good old Spider-Man meme. Okay, and the derivative of x is 1. So if we go ahead and plug in infinity, then we get positive infinity, or you can write dne, whatever floats your boat. Okie dokie, artichoke. Here we go. Number 3. What about this one? The limit as x goes to 0 of x over e to the x. And I know you're like, Schwarberg, it's clearly 0 over 0. Well, let's see. I mean, you don't know. You don't know. I don't know. So I plug in 0, e to the 0, that is 1. So, hey, is that 0 over 0? No, right, as Ella would say. This is just 0 over 1, which is 0. Hey, not always L'Hopital. Not always. Okay, how about this one? The limit as x approaches 0 from the left of e to the x over x. Okay, so if I plug in 0 here, we get 1. If I plug in 0 here, we get 0. Okay, so we have 1 over 0. So that is infinity. Okay, but notice it's coming from the left. I'm going to highlight this. from the left, from the left. Okay, so that means that my x values are actually negative, right? This is a negative. Okay, so it's going to be negative infinity. Or again, does not exist. All right, example 5. All right, so again, I'm going to go ahead and I want to evaluate the limits. So let me go see. If I plug in 0, that's 0. This gives me 1. 3 minus 3, hey, that's 0. Okay, and I plug in 0 down here. Hey, it's 0. All right, so good old L'Hopital. When I was in college, we had to do this. We had to say, like, by L'Hopital. That was like telling our professor, hey, I'm taking a derivative here. That's what I'm doing. You don't have to do that. Derivative of this. So, boop, boop, boop. Let me clean this up. Okay. Chain rule. So, we have negative 9 e to the power of 3x. That's the derivative. Okay, and then the derivative of the bottom is 1. So now I plug in 0. Okay, so again, this goes to 0. This is 1. And we get negative 9. Hey, pretty simple, isn't it, right? All right. Okay, so that's L'Hopital's. And then here's just like a disclaimer. Kind of like a watch out. Do not use L'Hopital's rule just because a problem looks like a candidate for a L'Hopital rule. Examples 3 and 4, they are not, right? So direct substitution didn't give us our indeterminate form, so don't always just assume, okay? You know what assuming does, all right? If L'Hopital's rule leaves you of the form 0 over 0 or plus or minus infinity over plus or minus infinity, then you can use the rule again. So it's possible to have a L'Hopital to L'Hopital twice, L'Hopital squared. And you can use this process as many times as you want, okay? So let's go ahead and check out some cases where that's going to happen. I'm going to switch away from the red. I think it's making me super crazy. So what's the limit as x approaches negative infinity of x squared over e to the negative x? Well, if I plug in negative infinity and I square that, that's going to be positive infinity, right? Negative times a negative. And then down here, if I plug in negative infinity, negative, negative, that makes e to the positive infinity, which is positive infinity. Okay, so I'm going to go ahead. I'm going to L'Hopital this. So the limit, the guy didn't even make up this rule. It was Bernoulli. He bought it. Isn't that crazy? He kind of like bought the naming rights, published in his book. Okay, so derivative of the top, 2x. Now derivative of the bottom, derivative of e to the x is e to the x, but then we have a chain rule. Boop. Okay, there we go. All right, let's go ahead. Now I'll switch colors. I'll go to green. If I plug in negative infinity, again, now it's negative infinity. And if I plug in negative infinity up here, we get negative e to positive infinity, which again is negative infinity. Hey, indeterminate. Okay, why are you freaking out? Sure, just do L'Hopital again. Oh, I can do that? Yes, you can. Okay, so as x goes to negative infinity, derivative of the top is 2. Derivative of the bottom is just going to give us, again, e to the negative x. And then with the hook, right, our chain rule, we will get a negative times negative, so that's positive. Okay, so then I'll go ahead and I plug in infinity, and we get 2 over infinity. 2 over infinity, okay, and that's just 0. All that work for 0 for nothing? That's calculus. All right, example 7. Limit as x approaches 1 the natural log of x minus x plus 1 over x squared minus 2x plus 1. So we'll go ahead, we'll plug this in. The natural log of 1 is 0 minus 1 plus 1, right? So this goes to 0. And in the bottom, if I plug this in, we get 1 minus 2 plus 1. So that goes to 0. Okay, indeterminate. So what we can do is take the derivative. Limit as x approaches 1. Derivative of natural log of x is 1 over x. Derivative of x is 1. And down here we get 2x minus 2, question mark, minus 2. Okay, so we'll go ahead and we'll now plug this in. So if I plug in 1, we get 1 minus 1. Hey, that's 0. And then down here, I plug in 1. That's 2 minus 2. That's 0. Okay, shucks. Shoot. Ah, shoot. That's what Ella says. Okay, so now I have limit of x as x goes to 1. And what I'm going to do is this is x to the power negative 1. You agree? Okay, I'm glad you agree. So now it's negative x to the negative 2 over, and then derivative down here is just 2. Okie dokie. Which is, if I just clean house, I have to straighten up. Slightly OCD. Negative 1 over 2x squared. Okay, and now through direct substitution, we get negative 1/2. And that's it. There's your answer. That's L'Hopital, y'all. All right. I hope you liked the video. L'Hopital. Take the derivative at the top. Take the derivative at the bottom separately. Not the same thing, okay? If you get indeterminate. 0 over 0. Positive minus infinity over positive minus infinity. Do not write equals 0 over 0. Do not. Do not. Catch you next time. Peace.